In today's video, we're going to be looking at scaled figures, figures that are being dilated, and determining the scale factor based on the grid that they are on. So in this first problem right here, it says the figure on the right, or it's on the bottom, is a scaled, on the right is a scaled copy of the figure on the left. So this is being dilated. It's important to know what direction is being dilated. This is going to that. All right. So, what side in the figure on the right corresponds to the segment EF? So, the segment EF, remember, corresponding means the same location. The same location. It's the corresponding side of EF, this one right here. Okay. So, the same corresponding side to EF is MP right there. So the corresponding side to EF is MP. Okay. Then it asks the scale factor. So you know it gets smaller, first of all. So you know it's going to be a fraction less than 1. Okay. Since it's getting smaller. What I do, and you don't have to use the corresponding sides that they asked about in the previous question. What I do is I just take any side and take a look and compare. So I look and the side corresponding to that. So EH is 1, 2, 3 blocks long. So this is 3. And then the corresponding side to EH is MO, which is just 2 blocks. So it is getting smaller. So it's a fraction less than 1. So it's the dilated figure divided by the original figure. So the scale factor in this case is 2/3. Okay, since it's getting smaller. Okay, so you take this, you can't reduce this fraction or simplify it any further. So it is just 2/3. Okay, let's look at another example, a little bit more tricky one. Now, this one might be a little bit tougher to see the corresponding side. So UV, okay, side UV right here. I'm going to do it in red. It's right here. Okay, now if I rotate this, it looks like it's being rotated 90 degrees, right? So it's being turned counterclockwise because you notice this point here is pointing up and it's pointing left. Okay, so the corresponding side when this is being turned is GH right here. Okay, so that is the corresponding side, GH. Now, to determine the scale factor, take the length. So this is getting bigger, so it's going to be a number greater than 1. And GH and UV are nice and easy to count. So UV is 1 block long. GH is 2 blocks long. So again, you always go from the dilated divided by the original. So 2 divided by 1, which is just 2. So that is the scale factor. It's getting double. This is being doubled in size. Okay. So let's take a look at another. All right here. Now this one, QO is right here. All right. And again, this is being rotated. So it's being rotated around, and it looks like the corresponding side to QO is, it's getting rotated all the way around, right? Because here's the little side NQ, and here's the little side. I know these two are corresponding. So it's going to be on the bottom of that, which is right over here. So you have to really use your visual skills and try to see, okay, which is the corresponding side. So QO and ST are the corresponding sides. Okay. Now scale factor. Now this one is tougher to determine the scale factor because they don't lie nicely on the grid lines. What I do is I look at the diagonal. Look at the diagonal. It's a lot easier to count the numbers on the diagonal. So the diagonal is 1, 2, 3, 4, 5, 6, 7 blocks. Okay. This diagonal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So your starts off at 7 and goes to 14. So it gets bigger. So dilated divided by the original, 14 divided by 7. I can reduce that to 2 over 1, which is just, you got it, 2. So again, this one is doubling in size. All right. So whenever you can't count any of the side lengths, use the diagonal. All right. And now let's look at the last one. Oh, okay. Right here. MO. So I have MO right there. And it looks like it's being, again, turned to HF right there. It's the bottom of the little, I guess, trapezoid. So MO and FH or HF. Really doesn't matter the order. Okay. What's the scale factor? Again, I can't really count the sides. So I'm going to use the diagonal. Okay. So the diagonal of this one is 1, 2, 3, 4, 5, 6 long. The diagonal of this one is 1, 2, 3. So this is just 3. And this one gets smaller. So it is 3 divided by 6, which reduces to 1/2. So this is actually half the size when it is dilated and rotated. Okay. So when you can't count the side lengths, the blocks and the side lengths, use the diagonals to help you. Okay. And if a number gets smaller, it's going to be a fraction less than 1. If it gets bigger, it's going to be a number greater than 1. So that's it for today's video. Thank you for watching. And always remember, whether you're solving for X or Y, always give math a try.